Welcome back, everybody. This is our 16th class in JEE Mains previous year questions for chapter Current Electricity. Before this, we have made 15 videos, and all of those videos can be found on our YouTube channel's playlist section. We have also started similar playlist for NEET previous years, so you can go to our channel and in playlist section can find those videos also. And if you find these videos useful, helpful, then do press the like button, share them as much as possible, and subscribe to our channel. Also, if you like to support us, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your donations, we will be able to keep on bringing you these quality videos on regular basis. And what any small amount will also be appreciated. So with this, let's start today's video. And in previous video, we completed up to one question number 130, 130. And today we will move forward. Uh, this was the last question which we completed. And today we will start with 131. So a 10 volt battery with internal resistance 1 ohm and 15 volt battery with internal resistance of zero point 0.6 ohm connected in parallel to a voltmeter, the reading of the voltmeter. So we have to find out a reading of the voltmeter. And as we can see that both of these batteries are in parallel. And when we have batteries in parallel, then their final EMF E is given by summation EI by RI, where RI is their internal resistance, divided by summation 1 by RI. Again, this RI is their internal resistance, or we can say resistance with them in series. So in this scenario, it will be 10 plus 1 plus 15 by zero point 0.6 divided by 1 plus 1 divided by 1 plus zero point 0.6. So this will be the final value. Now 15 by zero point 0.6, which we have to solve. 15 by zero point 0.6 can be written as like this, and it will be 5, 2, and this will go on 5. So it will be 25. So 10 plus 25, it is equal to 35 by 1 by zero point 0.6 can be written as 1 by 6 into 10. So it is 5 by 3, and 1 plus 5 by 3 can be written as 3, 3, 5, 8 by 3. So it will be 8 by 3 and 3 coming on the top. So this will be, we know 8 4 ja is 32 and 4 into 3 is 12. So it will be more than 12, but less than 24, of course. It is will be 5, 10, 8, 1, and we will be left with 13. So 13.1, option C will be the right answer. Moving to next one. In an experiment of potentiometer for measuring the internal resistance of primary cell, balancing length L is obtained on the potentiometer wire when cell is in open circuit. Now cell is short circuited by a resistance R, where R is equal to internal resistance of the cell. Balancing length on the potentiometer will be. So in this question, what we have done, or what is asked in the question, that suppose this is our potentiometer with some resistance and wire AB. This is wire AB. Now we are measuring internal resistance of a cell. Suppose potential of that cell is E and its internal resistance is R. And here we have jockey point. So initially at the null point, that EMF of this cell E should be proportional to length AJ, and that is given by L. This is the first scenario. Now in the second scenario, we short circuit it with a resistance equal to its internal resistance, equal to resistance of a resistance small r. Now in this scenario, what happens? Now in this closed circuit, we can name it like C, D, E, F. In this closed circuit C, D, E, F, there will be some current and potential across this this resistance small r will be balanced across jockey. Now suppose new balance point is AJ dash, or we can say L dash. So first current in this circuit will be I will be E by R plus R, that is 2R, and potential drop across this resistance R, VR, will be current times its value. So it will be E to R into R, that will be E by 2. So now this potential will be balanced by AJ dash. So we can say E by 2 is proportional to L dash. Now if we divide both of these equations, we will get E by 2 is equal to L by L dash, and from this we get 2 is equal to L by L dash, and L dash is equal to L by 2. So option C will be the right answer. Moving to the next one, it is preferable to measure the EMF of a cell by a potentiometer than by a voltmeter because of the following reason. In case of potentiometer, no current flows through the cell. The length of potentiometer allows greater precision. Measurement by the potentiometer is quicker. Sensitivity of the galvanometer when using a potentiometer is not relevant. And we have to find out which one of these correct. Now coming to the first point, in case of potentiometer, no current flows through the cell. So yes, it is right that in case of a potentiometer, when our system is at null point, so no current flow through the cell, and due to this we can measure actual potential. So one is right. Now more the length of the potentiometer, more the precision we have. So yes, second is also right. And measurement of the potentiometer is quicker. Yes, we can get a basic idea within very we can say less time. And sensitivity of the galvanometer is relevant in case of potentiometer. So this is wrong. Sensitivity of galvanometer is relevant. More sensitive is the galvanometer. With more accuracy we can measure EMF of the cell. So 1 2 3 will be the right. And here we have. So now out of these possible option, only option C fits to our criteria because it has 1 and 2, because we know 4 is wrong. Option 4 is wrong, so here it is wrong, here it is wrong, so only option C left for us. Next question. In a sensitive meter bridge apparatus, the bridge wire should possesses high resistivity, low resistivity. So option B should be the right answer, because I think, wait a minute. So let's coming to the point that what are the requirements for a wire of meter bridge. Now, when suppose this is the wire of meter bridge, when some current is flowing through it, then what will happen? When due to flow of current, due to current, there will be heat generated, and due to heat, there will be thermal expansion, which we already have studied in the class 11th. And thermal expansion, which type? Longitudinal thermal expansion. So we have to minimize this. We have to minimize this thermal expansion, and that we can do by reducing the current. And how we can reduce the current? So uh, increase resistance of the wire. And if resistance is higher, means resistivity is also higher. Indirectly we can say, it does not actually mean that resistivity should be higher. We can have a low resistivity material, with very small area of cross section. But normally we assume that resistivity will be higher. So higher resistivity. Now also coming to the second point, that temperature coefficient. Now what is temperature coefficient? Temperature coefficient decides that how much thermal expansion will be there. So we need least thermal expansion. We need least thermal expansion, and for that, that thermal expansion coefficient should be low, because we know that L expanded L or expanded length should is equal to 1 plus alpha delta theta. This is thermal expansion coefficient, so it has to be lower so that expansion is least. So high resistivity and low temperature coefficient, option A will be the right answer. Moving to next one. In a meter bridge experiment, null point is obtained at 40 cm from one end of the wire when resistance X is balanced against another resistance Y. So we can say X by Y is equal to 40 by 400 minus 40, that is 60. If X is smaller than Y, the new position of the null point from the same end if one decide to balance a resistance of 3X against Y. So we have to find 3X by Y. That we have to find out. Suppose it balance at length L, so it will be on the lower side. Denominator we will have 100 minus L. Now X by Y we know that is 2 by 3. So 3 into X by Y is 2 by 3. It's equal to L, 100 minus L. So it get cancelled, and we have 200 minus 2L is equal to L, or 200 is equal to 3L. Well, from this L is 200 by 3 or 66.6 centimeter, and most nearest answer is 67 centimeter. Moving to next one. The current in a primary circuit of a potentiometer is 0.2 ampere. Specific resistance. So we know value of I, 0.2 ampere. Specific resistance and cross section. So we can say rho is 4 into 10 to the power minus 7 ohm. Area 8 into 10 to the power minus 7 meter square. Potential gradient will be equal to potential gradient. So we know resistance R is equal to rho L by A. And potential, we can find out potential. V is equal to IR. So it will be I times rho times L by A. Now potential gradient is potential per unit length. So it will be V by L. So it will be I rho L by A by L. L get cancelled. I rho by A. I is 0.2. 4 into 10 raised to the power minus 7 and 8 by 10 raised to the power minus 7. So 10 raised to the power minus 7 get cancelled. We have 0.8 by 8 or zero point 0.1 volt per meter. Option C will be the right answer. Now moving to next one. Shown in the figure below is a meter bridge setup with null deflection in the galvanometer, the value of R. So according to the diagram with potentiometer formula, 55 by 20 should be equal to R by 100 minus 20, that is 80. So 4 R is equal to 55 into 4 means 200 plus 20, 220 ohm. Option B will be the right answer. Next question. In a Wheatstone bridge, the resistance P, Q, and R connected in the three arms, and the fourth arm is formed by two resistances S1 and S2 connected in parallel. The condition for the Wheatstone bridge to be balanced will be, okay, so we have four arms. This is first, second, third, and fourth. So here we have P, We can say here we have Q, here we have R, and here we have S1 and S2 in parallel. So S1 and S2 in parallel. So condition will be, balancing condition will be P by R is equal to Q by S1 parallel combination with S2. And their parallel combination, suppose, is represented by S, then S will be S1 S2 divided by S1 plus S2, and we can find S like this. So P by R is equal to Q by S1 S2 S1 plus S2, and we can swap P by Q, P and R and Q here. So P by Q is equal to R times S1 plus S2 by S1 S2. That is option B. Next question. In a potentiometer experiment, the balancing with the cell is at length 240 centimeter. On shunting the cell with resistance 2 ohm, the balancing becomes 120 centimeter. The internal resistance of the cell is equal to 2 ohms. Why 2 ohms? We just solved a similar example, similar question, sorry, where shunting it with internal resistance, the length got halved, halved. Here it is. We had initially we had a cell of EMF E, and its internal resistance was R, and its balancing length was L. After we added a parallel resistance that is equal to its internal resistance, then EMF got reduced to half, and after that we found out the relation between these two lengths, and that was also half. So using this, we can easily say that if length is reduced to half, means EMF should be reduced to half, and when EMF reduced to half, then parallel resistance is equal to, we can say, internal resistance, and that we can find out using a diagram or using this formula. That suppose initially cell had internal resistance R and EMF was E. Now this EMF E was balanced by 240 centimeter. Now we added a parallel resistance of 2 ohm. So now current in this circuit will be, I will be E by R plus 2, and potential across this 2 ohm resistance V2 will be current times resistance, so 2E by R plus 2, and this potential is balanced by 120 centimeters. So twice of E divided by R plus 2 is balanced by 120. Dividing both of these, so E by 2E R plus 2 is equal to 240 by 120, that is 2. E get cancelled. So we have R plus 2 by 2 is equal to 2, and from this R plus 2 is equal to 4, and R is equal to 2 ohms, which we already explained. Next question. In a meter bridge experiment, null point is obtained at 20 centimeter if one from the one end of the wire when the resistance X is balanced against another resistance Y. So if X is less than Y, where will be the new position of null point from the same end if they decide to balance resistance 4X against Y? We just previously did this type of question. Here X by Y will be 20 by 100 minus 20, that is 80, and we have to find balancing length for 4X by Y. So suppose that is L, so 100 minus L, and now X by Y is 1 by 4. So X by Y is 1 by 4. So 4 into 1 by 4 is equal to L, 100 minus L. And we have 100 minus L is equal to L. And from this L is equal to 50 centimeter. Option C will be the right answer. Next one. The length of a wire of a potentiometer is 100 centimeter and the EMF of this its standard shell is E volt. It is employed to measure a EMF of battery or internal resistance zero point 0.5 ohm if the balance point is L is equal to 30 centimeter from the positive and EMF of the battery will be. So battery EMF we have to find out. So if we draw basics diagram for this, we will have potential E, that is with length with wire AB of length 100 centimeter, and there is another cell whose EMF we have to measure, suppose E2, and its internal resistance is 0.5 ohm and it is balancing at length of 30 centimeter. So we can easily say that at the null point, as there is no current flowing through this part, so potential E2 should be equal to potential drop across AB wire up to length 30 centimeter. Now potential gradient for this wire will be E by total length, that is 100, and E2 is equal to potential drop up to 30 centimeter. So multiply by 30 centimeter. This is the potential drop on AB wire up to 30 centimeter, and that is equal to 3E by 10, or we can say 30E by 100, which is option D. Moving to next one. An ammeter reads up to 1 ampere. Its internal resistance is zero point 0.1 ohm. To increase the range to 10 ampere, the value of the required shunt is. So we have to find out value of required shunt. Now let's suppose as reading is maximum reading that can go is 1 ampere and internal resistance is zero point 0.1 ohm. So we can say we have a resistance of zero point 0.1 ohm here, and we have a galvanometer which whose maximum deflection is 1 ampere. Now we have to add a shunt value, suppose R here, so that its range increases to 10 ampere. Now we know that through this part only 1 ampere of current can go. So we can say if total 10 ampere current is passing, then out of that 10, 9 ampere is going through this part. Okay. So now we can easily see that if this is point A and this is point B, now from the upper side, potential AB, VAB is equal to current passing through the upper side into resistance. Now current passing through the upper side is maximum, that is 1 ampere. So it will be 1 into 0.1, 0.81. And from the lower side, it will be 9 into resistance, that is 9R. So 9R should be equal to 0.81 and R should be equal to 0.81 by 9. So means zero point 0.9 ohm. Option C will be the right answer. And moving to the last question. If ammeter has to be used, if ammeter is to be used in place of voltmeter, then what we must connect with ammeter? Now we know that for a ammeter, its resistance is practically very small, or we can say ideally zero. And for a voltmeter, its resistance is practically very high and ideally is infinite. So to convert a ammeter to voltmeter, we need to increase its resistance from 0 to infinity. So we need a high resistance in series with ammeter. So high resistance in series, option C will be the right answer. So with this, we end this video here. Hopefully what we have discussed till now is helpful to you and understandable also. Again, if you have any doubts, suggestions, put them in comment section. I will try to resolve them. And if you find this video useful, then press the like button, share with as much as possible. Also, if possible, do make some donations by scanning QR codes in front of your screen. So with this, again, thanks for watching, and we will meet in next video.